make a video. We're gonna delve through. First, I'm just gonna do all the linear stuff. These PowerPoints, I don't love all of them, but it's something. So I'm gonna knock these out, and then if I have time, well, when I have some time to spend more time on this, I'll go in and I'll re-edit and maybe add some different ones, more content. So I'm gonna go through linear, then I'll get into systems, and I'll probably go backwards. And then if you're looking for Algebra 2 content, that'll be coming soon. I'm trying to figure out what's most important. I got super glue on my hands. We were making leprechaun traps today. But let me know if there's specific things you want. So, all right, guys. So we're going to talk today about this Algebra Stacks. It's basically it's just notes. I'm trying to give you guys the condensed version of everything you need for slope. Slope's dope. Linear unit, here we go. So this could be an example of a note card you make to help you remember all these things. So slope, we see it in lines, and it refers to the steepness of the line and the direction. So is it positive, negative, 0, undefined? Does it have no change? Is it decreasing or is it increasing? No slope, you divide by 0. Dinosaurs die. Don't do stuff like that. But it really refers to this concept of rate of change. How quickly are things changing over time? And we talk about it as a ratio of rise over run. So in a graph, you'll see the rise over the run. And the rise is how much you're going up or down. It's always up or down. The run, we refer to how we're going to the right. You can go backwards, but then you have to do the opposite direction for the rise. Now, for the pink example, we got to rise, you got to get up, get that money. We got to go up 3 units, and then we got to go over 1 unit. So that refers to the slope as a ratio of up 3 over 1, which does simplify to a slope of 3. Now, the bottom half of this screen is touchy, so I'm not going to use the pointer for this one. But if you look at the orange, it's a negative slope. It's going down first. You go down and then to the right. So we go down 1 over 2. It doesn't matter if you start on these 2 points or these 2 points. You go down 1 over 2. That's a negative slope, negative 1 over 2. Every time you go down 1, you have to go over 2. Every time you go over 2, you have to go down 1. That's that relationship between the rise and the run, the delta y, delta x. So as you're just looking for the 4 types of slope, here you go. Quick review: positive, left hand down, right hand up. Things are going up over time. How much money you have after a day of working. The distance you have walked, if you're constantly walking at a same speed. Negative, you're spending money constantly. Negative, you're losing weight. The temperature is decreasing, etc. 0 slope, it's not changing. You're dead, flatline. But over time, you're not making any money. You're not getting any new boyfriends or girlfriends. You're lonely. Sorry. And then no slope, undefined, it just doesn't exist because you can't divide by 0. And the only time to get a vertical line is when you divide by 0. So that's when that happens. So to graph, you have to do rise over run. I will be washing my hands after this. Yeah, touch my face. Change in y, change in x. Now these are linear, so these are going up by the same amount every time. Talking about corona, it's not a linear. We'll talk more about that later. So this example, you have your 2 points marked. Now there's all types of pretty points. There's a pretty point. There's a pretty point. There's a pretty point. Pretty points line up directly on the axes. So you get 2 pretty points and you ask yourself, okay, which direction am I going? Well, it's a positive slope. We're going up 1, 2, 3 over 1. That's a slope of 3 over 1, which does reduce to 3. Up 3 over 1, 3 over 1. Your ratio is 3 over 1. That's your slope. Negative slope, got to go down first. You go down 1 over 2 from the pretty points. Now I could mark more pretty points. I see a pretty point right there. I see a pretty point right there. Another pretty point. It doesn't matter which 2 pretty points you go down, because let's say I started here and I wanted to get to the y-intercept at negative 2. I go down 1, 2, 3 over 6. That would be negative 3 over 6. That reduces to negative 1/2. Is the same slope. So equivalent fractions is important to know here. All right, here's some other things. We're talking about coordinates, ordered pairs. It's always x comma y. Generally, for lines, you want to graph a minimum of 2 points. I like having 3, but 2 is cool. And you have your first one, which is x1, y1, and your second one, which is x2, y2. You plot them. So in this case, if you wanted to use slope formula, this is slope formula right here, y2 minus y1 over x2 minus x1. That gives you slope. So if you take your first point and you take your second point and you label them as x1, y1, x1, y1, x2, y2, plug them into the slope formula, you'll get the same slope that you got from the graph. So this is an algebraic representation of what you saw on the line. And it works for positive, negative, all types of slopes. So that's slope formula. If you have more questions about that, let me know. Coordinate points. All right, so we have our order pairs here. This is just a little, a little more in depth. So you have 0.1, 0.2, or it could be 0.2, 0.1. It doesn't matter. But you got to make sure it's always x comma y. Your x-axis. Let me turn on my pointer. Sorry. Your x-axis is the horizontal, left to right. The y is vertical, up and down. Rise, run. Drill that in your brain. So you want to label your coordinates. You got to label your x1 and y1. So a lot of people tend to go x1, x2, x2, y1. Weird stuff. It's got to be together. The x1, y1, x2, y2. That's its point. Otherwise, you're literally putting a different point. And if the point doesn't exist on the line, slope formula is irrelevant. You can't find the slope. 7 and 4, 7 and 4, and then should be 1 and 0. Do the math. 3 over 1. Positive slope. We keep working with the same line because I'm trying to show you the connection between all these things. Slope is 3. M. M is the letter for slope. Negative slope, same deal. Again, it doesn't really matter. Now, you will find as you get good at this, there's certain ways to label the points where you end up with less negative numbers, but negative numbers are just a little trickier, no big deal. So you got your points. We'll label them. See that there? Plug them in, substitute. Now, I like putting these in parentheses, especially for these situations, so I will have to upload another video doing that, but hey, it works. Be careful. If you see a negative, negative, subtract a negative, you got to add the opposite. So that's going to be negative 3 plus 2 instead of negative 3, whatever else your brain's going to tell you, which was negative 1. Over 2, negative 1/2. You notice that we're getting the same slope every time because we're still dealing with the same function. Now we have a table. A table is just a collection of ordered pairs. This is relevant. A lot of data over time is tracked in tables. So if you're looking at the corona cases, that's in a table. And we're looking for a constant rate of change. It's that common difference we talked about. So you have to compare the change in x and the change in y. And you'll notice that it's the same. And if it's the same, you can pick a pair. It doesn't matter which pair to make the slope. So 3 is your change in y, which is your rise. And change in x is your run. So it's plus 3 over 1, which is what we know. Same thing for the negative slope, negative 0.5, negative 1/2, either way. And you end up with that negative 1 over 2 slope. Oh, for the table, make sure you know what your x and your y is. You're looking for the change from each coordinate. You're not looking at what that negative 2 is. You don't care about the negative 2. You care about what it is to get from negative 2 to 1. So it's plus 3, plus 3, plus 3, plus 3. Great, because we're going up by 1 on the left. So that's why that's the same. There are tables where it's not always exactly the same, but it's still linear. We'll talk about this later. 3 over 1. Slope is 3, still 3. Negative slope, going down by 1/2. See? On the x side, it's going up by 1. Write it as negative 1/2 over 1. Do the math. End up with negative 1 over 2. Slope-intercept form, this is our friend. It's the easiest way to graph. Usually you get y equals mx plus b. M is slope, b is y-intercept. This only works if you get y by itself, and you have to have slope, you have to have y-intercept, or this form doesn't help you. The purple equation is 3x plus 4 because the y-intercept, where it crosses the y-axis, is at 0, 4, and the slope is 3 because it's going up 3 over 1. The orange line starts isn't the word I'm looking for. The y-intercept, where it's crossing the y-axis when x is 0, is negative 2, and then you're going down 1 over 2 to get to the next point. Now, if I'm doing this by hand, I like to plot the y-intercept and then get at least one more point, sometimes 2 or more, So I'd plot this point, then I'd go down 1 over 2. If I wanted to make sure my line's nice and straight before I get that straight edge, go down 1 over 2, go down 1 over 2, keep plotting those points to make your line, because a line goes on forever and it's just a collection of ordered pairs. It's like getting a tattoo. Tattoos, I didn't get these lines dropped into my skin. It was a bunch of tiny dots. That's what this is essentially. So slope-intercept form, y equals mx plus b. Quick review. If you need to pause the video, take some notes, do it. Use Cornell notes. If you have questions, comment down below. Make sure you can identify slope and y-intercept. So here, you should be able to quickly see that the slope is negative 1/2, the m, and the b is -2. That's my quick little just recap, quick and dirty algebra stack notes on slope. Linearity is important. A lot of things in life are linear. Maybe not perfectly linear, but mostly, hourly wages, monthly bills, budgeting, monthly expenses, revenue streams, and all that stuff. Constant rate of change if you're moving, if you're driving at X amount, 65 miles an hour, and you're trying to go somewhere in 3 hours. How long is that going to take? That's all related to this idea of linearity. Linearity makes a line. It's constant rate of change. So I'm going to upload this. I'm going to keep working. Stay tuned. I'll keep getting you guys content. Make sure you guys subscribe. Spread the word. There's probably a lot of people at home. Get them in our network. We all fam. So let me know how I can help you. Learn something. Stay busy. Show some love down below.